Earlier in this unit, we learned how to multiply radicals, so I'm going to review that really quick in case we've forgotten. So the first step is to multiply the coefficients and the radicands, and then after you're done with that, you're going to simplify the radicand. So for example, consider 3 square root 2 times 4 square root 5. I'm first going to multiply the 3 times the 4 to get 12, and then I'm going to multiply the 2 times the 5 and get square root of 10. Okay, so simple as that. Some of them get a little more complicated though if I have to then simplify my final answer. So take a look at this first one. I'm going to multiply the 9 times the 5 and get 45. And then I'm going to multiply the radicals. 2 times 6 gives me the square root of 12. Now I notice that 12 has a perfect square in it. It can be broken up into the square root of 4 times the square root of 3. And I'm just going to bring that 45 down in front. The square root of 4 turns into a 2. So I have 45 times 2, bring down the square root of 3. And then 45 times 2 is 90 square root of 3. So that would be my final answer. So you have to remember to simplify your answer after you multiply. This next one looks a little scary, but it's really similar to the others. I just have 3 things I have to multiply. So I'm going to multiply the 4, the negative 8, and the 2. And you can use your calculator for that. You can go ahead and type that in. 4 times negative 8 times 2. And I get negative 64. So that's going to be negative 64 here. And then I'm going to go ahead and multiply what's underneath the radical. And that's going to be 3 times 15 times 2. That gives me 90. Now, I notice again that 90 can be broken up into a perfect square. So I'm going to bring down my negative 64. 90 breaks up into the square root of 9 times the square root of 10. Square root of 9 turns into a 3. Multiply that by the 64. And 64 times 3 is 192. So, negative 192 square root of 10 is my final answer. The next thing we have to think about is using the distributive property. So in these next 2 examples, I have a radical on the outside and then a set of parentheses. So if we remember the distributive property, that means we have to distribute the square root of 7 to both the square root of 21 and the square root of 10. When I do that, 7 times 21 gives me the square root of 147, and then the plus sign, plus the square root of 10. The square root of 147 can be broken up into the square root of 49 times the square root of 3. That's not square root of 10, that should be the square root of 70. And the square root of 70 doesn't have a perfect square in it, so I can't break it up. I'm just going to leave it the square root of 70. This becomes a 7, square root 3 plus the square root of 70. And that's my final answer. And this last one, same thing, distributive property. I've got to multiply the 4 times the negative 7 to get negative 28. Then I have to multiply the 3 times the 15 to get square root of 45. Plus, now I've got to multiply and distribute again. So I'm going to do the 4 here times the 5 to get 20. And then I'm going to do the square root of 3 times the square root of 21, which is going to give me the square root of 63. Now, it just so happens that both of these square roots can break up. So bring down that negative 28. The square root of 45 becomes the square root of 9 times the square root of 5. Bring down the 20. The square root of 63 becomes the square root of 9 times the square root of 7. Both these 9s turn into 3s. And now we just multiply. Negative 28 times 3 is negative 84. Bring down the square root 5. And then 20 times 3 is 60. Bring down the square root of 7. And that's your final answer. So that's multiplying radicals. Pretty straightforward. It just requires that extra step of simplifying those radicals when you get them in your final answer. The next thing we're going to talk about is division of radicals. And it's called, we're going to use something called the quotient property. So the quotient property says that if I have a square root of like a fraction, I can break that fraction up into two separate square roots, one on top and one on the bottom. Okay, so these are the steps I've laid out for you. So as you're doing these problems in your practice, you can always refer back to this list of 4 steps to help you remember what to do. So the first step is to always simplify your fractions first. So if I look at this example, square root of 7 over 2, 7 over 2 can't be simplified. So I'm going to go ahead and skip step number 1. Then step 2 says use the quotient property. So what that means is I'm going to take that square root of 7 over 2, and I'm going to rewrite it as the square root of 7 over the square root of 2. So that's step 2, is just to write them as 2 separate radicals. Now step 3 is the important, really important one. If a radical still exists in the denominator, we're going to rationalize the denominator by multiplying the numerator and denominator by that radical. And I'm going to show you what I mean by that. What that means is what we're going to do is I'm going to go ahead and write this down here. So I've got the square root of 7 over the square root of 2. And since I've got this radical in the denominator, that is a big no-no. None of your answers should have a radical in the denominator. It just shouldn't happen. So to get rid of it, I'm going to multiply the top by that radical, and I'm going to multiply the bottom by that radical. Now this is a sneaky little trick, because you're going to see what happens here. On the top, I'm going to get the square root of 14, and on the bottom, I'm going to get the square root of 4. But the square root of 4 turns into a regular 2, and I just bring that square root of 14 over. Now I don't have a radical in the denominator, and that numerator can't be simplified, so that's my final answer. Some of them get a little bit more tricky. Let's take a look at this first example. Square root of 6 over 8. My first step is to simplify that fraction. Now, I would check in your calculator if simplifying fractions is not your thing. So in your calculator, you can do 6 divided by 8. You'll end up getting a decimal, but remember, if you hit that math and then enter, it's going to give you a reduced fraction. In this case, it reduces to 3 over 4. So I'm now going to rewrite my radical as the square root of 3 over 4. My next step then is to split the radicals into 2 separate ones, and now see if I can simplify. I can't simplify the top, so I leave that as the square root of 3. The bottom turns into a 2. So my denominator is on a radical, top is simplified, so that is my final answer. The next problem, 15 over 27, I'm going to go ahead and again put that into my calculator. 15 divided by 27, see if I can simplify this. Math, enter, and I can. I get 5/9. So this becomes the square root of 5 over 9. When I split that into 2 radicals, I get the square root of 5 over the square root of 9. That crosses off to a 3, and I just bring the square root of 5 over, and that's the best I can do. 48 over 50, exact same process. I know that this becomes 24 over 25. Split that up into 24 over square root of 25. The square root of 25 goes away, and I'm left with the square root of 24 over 5. Now, the tricky part here is that I've got this radical up top that can be simplified. So I'm going to go ahead and break that square root of 24 into the square root of 4 times the square root of 6, and I'm going to leave that number 5 on the bottom. He stays. Now on the top, that 4 cancels out to a 2, bring the 6 over, and I'm left with this as my fully simplified radical. So you always have to check if you can simplify any part of the numerator or the denominator. Okay? An important note, if there's ever a time in the problem where you can simplify the coefficients or simplify the radicands, then you can go ahead and simplify both. So in this case, when I simplify this, I can get this is like saying the square root of 4 over the square root of 10. I can go ahead and simplify that top to 2 over square root of 10, but remember, I can't have a radical in the denominator, so I'm going to go ahead and multiply the numerator and denominator by the square root of 10. When I do that, on the top I get 2 square root of 10, on the bottom I get a square root of 100, and that cancels out to just a positive 100, and I'm left with 2 square root of 10 on the top. Now this 2 over 100 has to be simplified. So you can always check in your calculator by doing 2 divided by 100 and seeing if that simplifies. Get that fraction, and it does. It simplifies to 1 over 50. So when I go ahead and write my final answer, I'm not going to write the 1. I mean, you can put 1 square root 10 over 50, but you don't need to put the 1. It's invisible, so it's not necessary that you put the 1. Okay, so square root 10 over 50. Oh, wait, I made a mistake. Sorry, this should be a 10 right here. That's my bad. So then this would be a 5. So my final answer is square root 10 over 5. Easy mistake to make. In this case, I see that I've got 3 over 6. I know that reduces to 1/2, so I can put 1 square root 2 over 2. And again, I don't need to put that invisible 1. I can just write square root 2 over 2 as my final answer. And this last one, 2 things you can simplify. 27 over 9 gives me 3 over 1. And then 10 over 5, that reduces to the square root of 2 over the square root of 1. And on the bottom, this cancels out to 1 and that disappears. So I'm really just left with 3 square root of 2 is the best answer. Okay. So this is multiplying and dividing radicals. Be very careful about simplifying. It's your last learning target for this unit. As always, if you need help, you know where to go. Good luck.